The National Electrical Code, NEC Section 406.8b mandates ground fault circuit interrupter, or GFCI, protection for all electrical outlets and devices located within 6 feet of sinks and bathrooms. NEC Section 210.8 extends this requirement to encompass hand dryers and other permanently installed appliances situated in these areas. GFCIs offer a crucial additional layer of safety by rapidly interrupting the electrical current in the event of a ground fault. Ground faults occur when electrical current deviates from its intended path, flowing through unintended conductors, often involving water. Bathrooms present a heightened risk due to the potential for water to come into contact with electrical appliances, thereby creating ground faults. GFCIs are designed to detect such faults and promptly cut off power, significantly reducing the risk of electric shock or electrocution. There are specific limited exceptions to the GFCI requirement for hand dryers installed in bathrooms. Firstly, if the hand dryer is designed with double insulation and incorporates no exposed metal parts, it may be exempt. Secondly, if the hand dryer is permanently installed, securely fixed in place, and not readily accessible for routine maintenance or cleaning, it may also qualify for an exception. Utilizing a standard circuit breaker instead of a GFCI circuit breaker for hand dryers within bathroom settings can introduce a safety hazard and result in non-compliance with NEC regulations. In the event of a ground fault, a standard circuit breaker may not respond quickly enough to prevent electric shock or electrocution. To guarantee adherence to electrical codes and maximize safety, it is strongly recommended to employ GFCI circuit breakers for all electric hand dryers located within 6 feet of sinks or within the sink area of school bathrooms. GFCIs function by monitoring the balance of electrical current flowing between the supply and return conductors in a circuit. A standard circuit breaker is designed to protect against overloads and short circuits, but it is not designed to detect ground faults. A ground fault occurs when current leaks from a hot conductor to ground, which could be a person touching a faulty appliance. Even a small amount of current, such as 5 mA, can be dangerous and potentially cause electrocution. A GFCI is designed to trip when it detects a current imbalance of 5 mA or more, interrupting the circuit quickly, typically within 20 to 30 milliseconds, to prevent injury. The NEC mandates GFCI protection in various locations where there is a higher risk of electrical shock, including bathrooms, kitchens, garages, outdoors, and near bodies of water. The 6-foot rule is designed to cover areas where water is likely to splash or come into contact with electrical devices. The primary purpose of this code requirement is to protect people from electrical hazards. In the context of school bathrooms, where there is frequent use and potential for water exposure, the importance of GFCI protection cannot be overstated. Children and staff are particularly vulnerable to electrical shock, making it essential to implement the highest safety standards. Regular testing of GFCI breakers is recommended to ensure they are functioning properly. This can be done by pressing the test button on the GFCI device, which should cause it to trip. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Proper installation and maintenance of GFCI breakers are crucial for their effectiveness. Only qualified electricians should perform electrical work to ensure compliance with codes and safety standards. When selecting a GFCI breaker, it is important to choose one that is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all to ensure it meets safety and performance standards. Additionally, the GFCI breaker should be rated for the appropriate voltage and current for the circuit it is protecting. It's also important to verify that the GFCI breaker is compatible with the electrical panel in which it will be installed. Using the wrong type of breaker can create a safety hazard. In summary, adhering to the NEC requirements for GFCI protection in school bathrooms is essential for ensuring the safety of students and staff. By using GFCI breakers for hand dryers and other electrical devices near sinks, the risk of electrical shock can be significantly reduced. Regular testing and proper maintenance of GFCI breakers are also important to ensure they are functioning correctly. The NEC is a comprehensive set of standards that covers all aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. The purpose of the NEC is to provide a set of rules that, when followed, will result in a safe electrical installation. The NEC is updated every 3 years to reflect changes in technology and best practices. Local jurisdictions may adopt the NEC as law, which means that compliance with the NEC is mandatory. Electrical inspectors enforce the NEC and can issue fines or require corrections for non-compliance. The NEC also provides guidance on the selection and installation of electrical equipment, including circuit breakers. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When a circuit breaker trips, it interrupts the flow of electricity to the circuit, preventing damage to equipment and reducing the risk of fire. There are different types of circuit breakers available, each designed for specific applications. Standard circuit breakers are designed to protect against overloads and short circuits, but they do not provide protection against ground faults. GFCI circuit breakers, on the other hand, are designed to protect against ground faults in addition to overloads and short circuits. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which are a common cause of electrical fires. SIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. The NEC also provides guidance on the sizing of circuit breakers. The size of a circuit breaker should be based on the ampacity of the conductors it is protecting. The ampacity of a conductor is the maximum amount of current it can safely carry. The NEC provides tables that list the ampacity of different types of conductors based on their size and insulation type. It is important to select a circuit breaker that is properly sized for the circuit it is protecting. A circuit breaker that is too small will trip frequently, while a circuit breaker that is too large will not provide adequate protection. The NEC also provides guidance on the installation of circuit breakers. Circuit breakers should be installed in a panel board or enclosure that is properly grounded. The panel board or enclosure should be located in an accessible location and should be protected from physical damage. Circuit breakers should be labeled to indicate the circuits they are protecting. The NEC also provides guidance on the maintenance of circuit breakers. Circuit breakers should be inspected regularly to ensure they are in good working condition. Circuit breakers should be tested periodically to ensure they are tripping properly. Circuit breakers that are damaged or not functioning properly should be replaced immediately. In addition to the NEC, there may be other codes and standards that apply to electrical installations. Local building codes may have additional requirements for electrical installations. State and federal regulations may also apply. It is important to be familiar with all applicable codes and standards when performing electrical work. Electrical safety is a critical concern, and it is important to take all necessary precautions to prevent electrical accidents. Always turn off the power before working on electrical equipment. Use insulated tools and equipment. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The use of GFCI protection is just one of many safety measures that can be taken to prevent electrical accidents. By following the NEC and other applicable codes and standards, and by taking appropriate safety precautions, you can help ensure a safe electrical installation. Remember that electricity can be dangerous and that it is important to treat it with respect. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Electric shock is a serious hazard that can cause injury or death. By taking the necessary precautions, you can significantly reduce the risk of electrical shock. The NEC is constantly evolving to keep pace with new technologies and changing safety needs. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. Many resources are available to help you learn more about the NEC, including books, websites, and training courses. The National Fire Protection Association, or NFPA, offers a variety of resources related to the NEC. Local electrical contractors associations can also provide information and training on the NEC. By investing in electrical safety education, you can protect yourself and others from the hazards of electricity. The National Electrical Code provides detailed requirements for ground fault circuit interrupter protection in various locations. For dwelling units, GFCI protection is required for 125 volts through 250 volts receptacles supplied by single-phase circuits rated 15 amps and 20 amps installed in bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens and sinks, boathouses, and laundry areas. For other than dwelling units, GFCI protection is required for 125 volts through 250 volts receptacles supplied by single-phase circuits rated 15 amps and 20 amps installed in bathrooms, kitchens, rooftops, and outdoors. There are also specific requirements for GFCI protection near bodies of water, such as swimming pools, spas, and hot tubs. GFCI protection is required for all receptacles within 10 feet of the inside walls of a swimming pool, spa, or hot tub. There are also requirements for GFCI protection of electrical equipment used in or near swimming pools, spas, and hot tubs. These requirements are designed to protect people from electrical shock hazards associated with water. The NEC also provides requirements for ground fault protection of equipment, which is different from GFCI protection. Ground fault protection of equipment is designed to protect electrical equipment from damage due to ground faults. Ground fault protection of equipment is required for certain types of electrical equipment, such as large motors and generators. The requirements for ground fault protection of equipment are based on the size and type of equipment. The NEC also provides requirements for grounding and bonding of electrical systems. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current to flow. Grounding and bonding are essential for electrical safety, as they help to prevent electrical shock and reduce the risk of fire. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding and bonding conductors. The NEC also provides requirements for surge protection. Surge protection is designed to protect electrical equipment from damage due to voltage surges, such as those caused by lightning strikes. Surge protection devices, or SPDs, are installed in electrical panels and at individual electrical devices to protect them from voltage surges. The NEC provides requirements for the selection and installation of SPD. The NEC is a complex and comprehensive document, and it is important to consult with a qualified electrician to ensure that your electrical installations are safe and compliant. The NEC is constantly being updated to reflect new technologies and changing safety needs. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. There are many resources available to help you learn more about the NEC, including books, websites, and training courses. The National Fire Protection Association, or NFPA, offers a variety of resources related to the NEC. Local electrical contractors associations can also provide information and training on the NEC. By investing in electrical safety education, you can protect yourself and others from the hazards of electricity.